Cool, we learned so far lots of awesome, very interesting concepts in operating systems and specifically in Linux. And I hope by now you already feel very knowledgeable in this area. There is, however, a very important concept still missing in order to feel like a pro in Linux, and that is networking. How does computer networks work? How do computers connect to the internet? What is an IP address and a port or a DNS and so on? And we will learn all of this in this lecture where I will explain all the main concepts step by step with examples. So let's get started. First of all, imagine your home network for your house where different devices like your computer and laptop and phone are connected to that network. Such a network is called a LAN or local area network. So LAN is a network of a bunch of devices connected together in one physical location. This can be as small as a private house LAN or LAN of a huge office building or a school campus with hundreds of devices. And each device on this network is identified by a unique IP address, where IP stands for Internet Protocol. So devices can talk to each other on the network using this unique IP address. For example, if your computer wants to send a printer something to print, it must know the printer's IP address and send the information there. This is an example of an IP address, 172.16.0.0. So IP address is basically a 32-bit value. One bit is essentially a value of 1 or 0. Now, we don't need to go into details here, but important to know that an IP address or IPv4 address is composed of 32 bits. So basically 32 ones or zeros here. And what are those dots between them? Well, every 8 bits are grouped into an octet, and each octet can be represented as a decimal number that we humans can read. Like this octet here represents 172. This one represents 16, and so on. So octet with all zeros, so 8 zeros is just a 0. And an octet with all ones, so 8 ones is a number 255. That means that IP address value can be any combination between 0.0.0.0 and 255.255.255.255. So that's how IP address is made up. But how do devices know each other's IP addresses, or how can they send things to each other? Well, that is a task of a special device on a local area network called a switch. So switch sits within the LAN and knows all the IP addresses of all the devices and therefore helps them communicate with each other within that local area network. Great, so your laptop can talk to a phone or a printer in LAN using a switch. But what if you want to talk to a server or some other device which is not in your LAN? Like you want to open Facebook website on your laptop, so you need to connect to and talk to a Facebook server which is obviously outside your LAN. Or essentially any website which is hosted on a server outside your LAN. Does switch help there too? No, for connecting to outside devices, there is another special device in a LAN called a router. Router is a network device that sits between the local area network and the outside network, which is also called a wide area network or WAN. So the router connects devices on local area network and wide area network, which means the router connects you to the internet. Back to our Facebook example, if you want to open Facebook app on your phone will send a request to the router. Then router will send that request to Facebook server over the internet. And the IP address of the router is called a gateway. So when you hear the term, router and network gateway are basically the same thing. Now the question is, when a device in LAN sends a request to another device, how does it know whether that other device is within the LAN or it's outside the LAN in the wide area network? Well, this is decided based on the IP address of the target device. Remember, as I said, that every device on LAN has a unique IP address? Well, these IP addresses aren't random. They all belong to the same range of IP addresses to identify devices in the same network. And that IP address range is represented by a concept called subnet or subnetwork. This is how an IP address range for a LAN can look like. So the first part here is the IP address, and that's the starting point of the IP address range. So that's the first IP address in the range. And the second one is what's called a subnet mask. So subnet basically sets the range, and it defines that whatever IP address of a device starts with 192.168.0. So whenever an IP address starts with this, it belongs to the LAN. If we change the subnet mask value from 255.255.255.0 to 255.255.0.0, then this will define an IP address range that starts with 192.168. So all the IP addresses that starts with these two numbers belong to the same LAN. So as you see, the value 255 fixates the IP block or octet, and the value of 0 means a free range. Why 255 and 0? Because as you learned, each IP decimal block can have values from 0 to 255. So anything within that range. So basically, subnet defines how many bits in the IP address are fixed, making the rest of them flexible. So 255.255.0.0 means that half of it, or 16 bits, are fixed in the IP address. This, on the other hand, means that a third of all the bits, or 24 bits, are fixed in the IP address. So again, when we're using this as a subnet mask, it means that those first three octets or decimal values cannot change, right? So the IP addresses of this LAN here will be between 192.168.0. So the first three cannot change, they are fixated, and the last one can change, and it could be all the way up to 255. So your IP addresses will be within those ranges. And right here, we have only half of it fixated. So your IP addresses of this LAN will be from this IP address to 255.255. So within this range. That's how it works. And as we said, this subnet mask number basically dictates how many bits in this 32-bit IP address are fixed. So based on this logic, there is actually a shorthand way of writing this, which is also called a CIDR block, and is written like this. So the same IP address as we have here, /16 or /24, where 16 and 24 represent the number of bits in the IP address range that are fixed. Just to recap, with subnet and a starting IP address, we have a range of IP addresses that are available in the LAN. So every device in that local area network will get an IP address from that range. So when we send a request to an IP address within our LAN, the request will go to the switch and it will forward it to the device within the LAN. If the IP address is external, it will go to the internet through the router. And that means any device on your network will need 3 pieces of data to communicate with other devices, both within its own network and to the outside network's devices. And this is the IP address, subnet, and gateway. Now we said that internally in a LAN, we have an IP address range that a network administrator of a company or school, or in case of your own house, your internet provider chooses, and that each device will get a unique IP address from that range. And suppose a device in our LAN is talking to a device in another LAN. Now, how do we make sure not every network administrator selects the same range and that the IP addresses in our LAN don't overlap or aren't the same as someone else's LAN? Well, the way it works is that the IP addresses of devices that belong to a LAN are not visible to the outside network or internet. So when you send a request to Facebook from your laptop's IP address from the LAN range does not arrive at Facebook server. Instead, it's replaced by the IP address of the router. And this functionality of router is called a network address translation, or NAT. So basically, when a laptop sends a request, it goes to the router, because router is the connection to the outside network, right, to internet. And router will then request that on the device's behalf from internet, and the response will then be sent back to the device. And NAT is a very important concept and has two main advantages. One of them is security and protection of devices on the LAN, because your IP address isn't directly exposed and no one can talk to it directly. And the second one is that we can reuse IP address ranges multiple times without conflicting with each other. So two huge companies can have the same IP address range within their own local area network, and they will basically not know about each other, so there will be no conflict. And this is very efficient because there are a limited number of IP addresses you get from the IPv4 address range, which is, as we saw, 4 zeros and 4 255s. And sure, there are lots of combinations between them. However, there are also lots and lots of devices in the world that need IP addresses. Now, what if an outside device wants to talk to your LAN directly? Like, you have a server that runs your application, so you want to be able to accept requests from devices outside your LAN. Well, by default, this kind of communication will not be allowed because of a firewall. So what is a firewall? Firewall is a set of rules that protect a network from unauthorized access. And you can explicitly define what kind of communication you want to allow to your network using firewall rules. So how does it work? You define which device on your network with a specific IP address should be accessible. You can also define which other devices or what IP addresses specifically can access your server. Or you can say, I allow any device on the internet to talk to my server. And this is usually the case when you're running a web application because you want everyone to be able to access your application. So for most servers that are running some applications, you will need to configure firewall rules to manage the access configuration. Now, there is one more important thing that you always define in a firewall rule, and that is which ports are accessible on the server, or generally on the device that you want to allow access to. So what is a port? Every device has a set of ports, and ports are like doors to the same building. You unlock some doors so the guests or requests can enter, and you keep others locked so no one can enter there. Or you unlock them only for specific guests, like a specific IP address that can enter that door, so to say. So with firewall configuration, you define which doors of the building or your server, in this case, you want to unlock, and for which guests or for what requests. And different applications and programs that run on the server will start or listen on different ports, meaning you can access that application on the device only on that specific port. And to keep this all standardized, there are default or standard ports for many applications. For example, most web applications start on port 80. So they are accessible on that port from the browser when you request the application. That means when you type facebook.com or google.com in the browser, by default, this request goes to a machine where Facebook or Google application is running on port 80. So on those machines, the firewall was configured to unlock the port 80 to accept browser requests. Other applications like databases also have standard ports. Like a MySQL database is usually accessible on port 3306, PostgreSQL on port 5432, and so on. So for every application, you need a port to communicate. And each port is unique on a device. So you can't have two applications listening on the same port. If you try to start the second application on the same port, you will get an error which says port already in use. So the firewall configuration allows a specific combination of device IP address and port to be accessed. So firewall is like a guard that is standing in front of the building and checks and verifies who can enter which door. And that configuration is also called port forwarding configuration. Now, when talking about networking, there is one more concept that is essential to understand and probably something you've heard very often, and that is a DNS, or Domain Name Service. DNS is basically the thing that the whole networking relies on. So let's see exactly what a DNS is. We know that every computer on the network is uniquely identified by its IP address. And we saw that every device can talk to any other device using its IP address. But when you visit Facebook application, do you type in the IP address in the browser? Or when you visit any other website, you never just type an IP address, right? Why is that? Because Facebook.com application runs on many computers which each have their own IP address. A website of your favorite local restaurant is available on a specific computer with an IP address. So every single application that is running on a machine is accessible by an IP address. So why do we use the names of the application instead of the IP addresses? Simply because we're not computers. Humans remember words and names better than IP addresses and numbers. So to make using the web easier for humans, the concept of mapping the IP addresses to names was introduced. So we access every application by typing the name. But the network, as we saw, doesn't understand the names, it understands numbers and IP addresses. So under the hood, that name gets translated into the actual IP address where that application is running, which then your computer can send the request to. And the service that does this translation is DNS. So using DNS, we can give a unique name to any IP address. So you can think of a DNS as an address book or yellow pages of internet. But considering there are so many websites and applications in the world and new ones being added daily, and so many servers in this world connected to the internet, how does DNS manage so many addresses and their names? DNS uses a simple policy of dividing all these names into different domains or groups. Domain names follow a hierarchical structure. There are around 13 root domains across the globe, with names from A to M, and under each root domain you have a hierarchy of what's called top-level domains, or TLDs. There are 6 original and most common top-level domains, and each domain has a specific purpose. We have .mil, which is for military applications. Then we have .edu or edu. This is for educational institutions and their websites. Then we have .com, which is more general purpose and usually used for businesses because com stands for commercial. Then we have .org, which is for non-profit organizations usually. The next one is .net, originally for networking technologies like internet service providers or any other infrastructure provider companies, but today it's more general purpose and can be used by all types of businesses. And finally we have .gov, which is for government. Apart from these original top-level domains, there are geographical domains which were added later. These are domains for each country. This is used to also regulate domain names for companies that are registered in that country. Examples would be .de for Germany, .us for US, .uk, .fr for France, etc. This makes sense if your website is in the local language and your visitors are local from that country, like local restaurants, shops, etc. And finally, a bunch of other domains were also added, like .biz, .int, .dev, etc. So basically, whenever someone creates a website, they can buy a domain name that belongs to one of these domains, like mywebsite.com or mywebsite.uk, and you may buy it for a year, and if you don't need it anymore, someone else can buy the domain name later. Now, who actually manages these names, or who can sell those domain names to you or keep track of which ones are already taken and which ones are still available? Or who decides how these domains are grouped or divided? Well, this is all regulated by a dedicated organization called the Internet Corporation for Assigned Names and Numbers, ICANN, which basically manages all these domain namespaces, and it also authorizes domain name registrars through which domain names may be registered and reassigned. And obviously you don't have to remember this organization's name, but I think it's interesting information to know that there is actually a dedicated organization that manages all these domain names. So as I said, every domain name actually belongs to this root and one of its top-level domains or geographic domains. Now suppose I want to create my own website and let people visit it, like TechWorld with Nana website. First, I select the top-level domain that I want for it, in my case .com, and create a domain for techworldwithnana.com. Now let's say I have 3 servers with 3 different applications which all belong to my company. So they are in the techworldwithnana.com domain. I can assign each one its own domain name using a concept called subdomains, like bootcamp.techworldwithnana.com or workshops.techworldwithnana.com and then courses.techworldwithnana.com. And many companies and many organizations actually use these subdomains for different applications that all belong to that organization. So each application may run on its own dedicated server, and each server that has its own IP address will now have a full domain name with which you can access it. There's also a fully qualified domain name, which will be courses.techworldwithnana.com where at the end is for root domain. But we don't use the fully qualified domain names. It works without at the end as well. Great, so we understand what DNS is, but how does your computer actually use the DNS service to map the domain name to an IP address? Every computer has a DNS client pre-installed. So when you open a browser and type in facebook.com, your operating system will make a DNS query asking DNS to resolve that facebook.com address or find the IP address that maps to facebook.com. The DNS request first goes to the recursive name server, which is typically operated by your internet service provider. And your recursive name server might have the IP address already stored, but if it doesn't, it will go to one of the 13 root servers, which manage requests for top-level domains. These root servers are redundantly available all over the world so that you get your response quickly. The root server will then look at the address and see .com, and it sends a response back to the resolver saying, I don't know what the address of facebook.com is, but here's the address of the .com's domain server, which you can ask. The resolver then asks the .com server, hey, can you give me the IP address of facebook.com? The .com server sends a response. I don't know the IP address of facebook.com, but here is a list of the IP addresses of the authoritative name servers for .com domain. They will know facebook.com's IP address. So finally, resolver chooses the IP address of one of the authoritative name servers from the list, asking for facebook.com's IP address. And this time, the name server responds with the actual IP address of facebook.com. So now your computer can send the request to Facebook's IP address. Now imagine this process happens every time you visit a website for the first time. But to save time in the future and make things more efficient, both the recursive name server and your computer will cache the DNS entries for a while so that the next time you want to visit the same address, it won't have to go through this whole process. At this point, you know all the essentials of networking. And if you want to see the networking information on your computer, there are various useful programs or commands for that. For example, with ifconfig command, you can get your computer's IP address, subnet mask, gateway address, which is again the router IP address, and a bunch of other information about your network. There's also a very useful command called netstat that shows you what active connections you have on your machine. Active connection means which applications are actively listening on their specific ports. A typical use case can be if an application on your server is not accessible and you're getting connection refused error, for example, you can check with this command whether that application is actively running or not and on which port it's listening. You can also check current running processes and programs and their information, including on which ports they're running, as well as how much computer resources they are consuming, using a ps-aux command. Using an NSLOOKUP command, you can get an IP address of any domain name. This command also displays the IP address of the DNS server your computer uses. Or you can also do a reverse check with NSLOOKUP command to show what domain name is attached to a specific IP address. And last but not least, a very simple command, ping, that basically checks whether a service or application is accessible. So you connect to or ping an IP address or domain name of an application and it shows you whether that address is accessible or not. You can use all these commands to basically troubleshoot your network when something is not working. And you can also use switches or different parameters for all these commands to enhance the command capabilities and display more information or display information in a different format, for example. For that, you can reference the documentation of all these commands. So as a DevOps engineer, you don't need to be a networking expert, obviously, but with this foundational knowledge, you will understand a lot of things much better in your DevOps tasks, and it will make your learning path much easier. And we will use some of these commands and many of these concepts throughout the bootcamp, so you will see some real use cases for them.